All right, welcome to In Limbo, Managing Transitional States. I'm really excited to be here. As Svetlana said, I'm Jeremy Smith. I am a product-focused Rails developer. I run a tiny one-person Rails studio called Hybrid. I've been doing that since 2013. I co-host the Indie Rails podcast with my good friend Jess. I do have stickers in the back on the sticker table, so grab one if you want one. My latest side project is called Liminal. It's a fresh take on old school forums. If you miss forums and are tired of chats, check that out. Love to talk about that with you. And you can find me most places online at Jeremy Smith Co. The title of this talk is pretty cryptic, so we're going to start here. What exactly do I mean by limbo? Your first thought might be that the contest that involves bending over backwards and passing under a horizontal pole, lowered slightly for each successive pass. But instead, I'm referring to the secondary definitions of limbo: an intermediate or transitional place or state, or a state of uncertainty. When I started working on this talk, I remembered that In Limbo is the name of a Radiohead song found on their album Kid A. In it, we find these lyrics: Lundy, Fastnet, Irish Sea, I've got a message I can't read. I'm lost at sea, don't bother me, I've lost my way. It turns out Lundy, Fastnet, and Irish Sea are three nearby areas on the BBC's shipping forecast. This song is about the transitional state of being at sea. Being in limbo is embarking on a sea voyage, having left one shore of safety and not yet having reached the next. The sea is an ancient symbol of chaos and danger. While there are great benefits to be gained by going to sea, there are also significant risks. In seafaring, a decision is made to make a lengthy and involved move from one position of relative safety to another to gain for some perceived advantage. During the transition, risk and uncertainty are increased. It's possible to get lost, the available resources are fewer, and the conditions may be more difficult and dangerous. But during the transition, all the functions must continue and can't be suspended. I think the same situation arises when building software. And so when I'm referring to being in limbo, I'm talking about the incremental process of making a complex change to a software system in use. Let me break that down a little bit. Why do I say in use? Well, if you are making a complex change to a greenfield application with no users right now, there's essentially zero risk to landing all those changes at once. Or if you're building a feature in an existing application that is not yet connected to anything else and is hidden away from users, again, you can probably just make that change. Why complex? Well, if the change is simple, can be reviewed easily, can be rolled back with little or no impact to users, then the risk is low in making that change all at once. And why do I say software system? Because these changes aren't limited just to code. They may be changes to schema, data, infrastructure, as well as conceptual and operational changes for the people involved. That's the end users of the system, as well as the people that are tasked with understanding and maintaining that system. It might be helpful to talk about some examples of different kinds of complex changes to systems in use. Let's say you work in a Rails app that uses the paranoia gem for soft deletion. Paranoia takes an implicit approach to soft deletion by overriding active record behavior, which can lead to some confusion as the destroy method soft deletes records and the really destroy bang method actually deletes records. On top of this, you discover that you're losing data when a model with soft deletes has a has-many association to another model without soft deletes because the association is set to dependent destroy. So you decide to switch to the discard gem, which takes a more explicit approach. It uses discard to soft delete records instead of overriding destroy, but it requires you to explicitly filter out all soft deleted records in all of your queries now using the kept scope. Or let's say you work on an app where users have one of three possible roles, managed by a role enum on the users table. After some time, the team has determined that the app needs to allow users to have multiple roles tied to their team memberships, but all the privileges and auth checks for existing users must be maintained during that transition process. Or let's say you work on a system that analyzes documents with highly variable content and derives consistent structured output that's surfaced to users. For the sake of simplicity, let's say that one of the most important outputs is the unique word count of the document. But you discover that the unique word count algorithm that's been in use for several years isn't always handling word boundaries correctly, and it's also extremely slow when processing certain documents. You need to rewrite the algorithm and regenerate the unique word count for hundreds of thousands of documents in production, but ensure that the accuracy of the new word count is the same or better than the previous word count. Now, someone might push back at this point and ask, do these complex changes have to be incremental? Why can't we just make an all-at-once switchover? We'll assign one team member to build out all the changes in a separate branch over the course of several weeks, and then we'll pause all the merges to our development branch, merge in the new changes, resolving all the conflicts, block off time over a weekend to deploy the changes and cut the system over, and then just remain on call in case there are problems. Now, I'm sympathetic to this idea. It seems like the incremental approach will take twice the time as the all-at-once switchover. Or it may even seem like there's no reasonable way to break down these changes into smaller steps. But this perspective is overly optimistic. How so? First, it assumes that the work of maintaining and then merging in long-running branch can be accomplished with few defects and regressions, within the limited time frame that other changes are being held back. It also assumes that the volume of problems faced after the switchover can be reasonably managed by the team and resolved before that weekend is over. It doesn't factor in the potential for failed cutover and the work of reverting the changes and then trying again. It puts an unnecessary cognitive load on the team members by requiring them to hold a full understanding of both the before and after state of the system. During reviews, it expects them to notice a needle in a haystack, the smallest bug in a gigantic diff. Yet it puts undue stress on team members by shifting all the risk and uncertainty around the change to a small window of time, and if things go badly, it risks depleting team morale. I'm going to share two stories of different kinds of system transitions that I've made to Rails applications on client projects in the past couple of years. As a fractional Rails developer, I work on small applications with small teams. Your circumstances are likely more complex in terms of team size, lines of code, request volume, scaling challenges, connected systems, and so on. So while my examples may be simpler than the systems that you work in, I'd like to suggest that higher complexity only makes it more critical to identify these limbo states and establish good practices within them. So a couple of years ago, I was working on a client project where we decided to migrate from Bootstrap 3 to Tailwind. And I had some constraints. We couldn't stop all of the work on this app until this project was over. There were still bug fixes to be made, minor dependency upgrades, and some features to build along the way. This migration needed to be pausable for a week or a month without causing problems. I knew from experience that I didn't want to maintain a long-running branch for this work, and I didn't want to do an all-at-once switch over to Tailwind. The long-running branch would make integration difficult and build risk to a point of crisis when that final merge happened. And changes to views are often particularly heavy diffs with lots of line changes. I find there's a significant fatigue factor when reviewing changes to the view layer in particular, and it's very difficult to spot errors. And while it wouldn't be ideal to live for a period of time straddling two CSS frameworks, I knew that an all-at-once switchover would be asking for surprises leading to production incidents, support issues, rollbacks, and potential rework. There's another thing I knew I didn't want during this project, and that was no side quests that would increase the scope of the project and put the main goal, switching from Bootstrap to Tailwind, at risk. Let me underscore this one. Side quests are a huge temptation. It's understandable to think that while you're already in all these views making these changes to migrate to a new CSS framework, this would also be a good time to do design updates to the app, or extract new helper methods, or switch all partials to strict locals, or even migrate to view component. But in general, I think this is a mistake. Doing so means it's much more difficult to maintain continuity in the app. The change sets are even larger and more difficult to review. And in the case of design updates, it may unnecessarily tie dependency changes to the design approval process, leading to slower reviews and more friction. With all these things in mind, here's how I approached the project. First, I did a review of how we were using Bootstrap in the app. I had a good idea I've been working on this app for a year or two, so I already had a good idea, but it's important to do a review and deeply understand how change to dependency will affect the system. For example, which default components are being used by Bootstrap? What Bootstrap JavaScript is being used? Is the provided icon set being used, or is it another one? Are there any Bootstrap extensions being used? How has the framework been extended or modified? How much custom CSS depends on the existence of Bootstrap classes? What Bootstrap classes are being relied on for custom JavaScript and tests? Out of the discovery phase, I needed to get clear on two things: destination and inventory. During discovery, it's important to articulate what the end goal is, or what parity will mean for the project. In other words, for the project to be successful, what needs to be the same before, during, and after the transition, and what is acceptable if it's different. When it comes to CSS framework changes, the closer you need to be to perfect interface parity, the more expensive it is to achieve. There was not a hard requirement for my client in this case, so my goal was to be reasonably close so that navigating between a Bootstrap page and a Tailwind page would not be jarring to users, but not going so far as to require all views to be visually identical. The other piece to come out of discovery is an inventory. It's important to have an inventory so you understand the scope of the changes involved and can make estimates more easily and can track progress across the items. In this case, I needed an inventory of views, partials, and helpers relying on Bootstrap. I also needed an inventory of other Ruby and JavaScript libraries that made use of Bootstrap, as well as any custom extensions. Along the way, I identified some work that could be done ahead of even starting the framework migration, things that could simplify the process for me. We had an admin layout that had very few differences from the default application layout, so I was able to consolidate the two and add a conditional check where it went in the admin context. Navigation is often one of the most complex areas around CSS and apps, I find. These are simplified examples here, but I consolidated multiple navigation partials and extracted navigation-related helper methods to reduce duplication and minimize the markup and class changes when updating to navigation to Tailwind. This would also be a good place to decouple Bootstrap classes from custom JavaScript and tests. For example, you might have JavaScript event listeners on form control inputs, or specs that check flash text in an alert div. With my inventory in hand, the preliminary tasks out of the way, I now needed to do all the setup that would support using Tailwind without hindering use of Bootstrap. In my application controller, I added a CSS framework helper method that would default to Bootstrap, but that I could override with a query string parameter to Tailwind, allowing me to convert controllers one at a time with a way to force the view to the other for manual testing. I added the Tailwind dependencies, set up a new entry point, and conditionally loaded assets based on CSS framework. What you may notice here is that we were also in limbo between Sprockets and Webpacker at the time. Next, I split out separate versions of the Bootstrap and Tailwind partials for common and shared parts of the layout, such as navigation. I also split out separate versions of Bootstrap and Tailwind helper methods used for navbar and links. One trick here is to make the destination the default and the origin the special case. So the original Bootstrap version of all the shared partials were moved into a Bootstrap subdirectory, leaving the Tailwind partials in the original and final location. I also prefixed all the original Bootstrap helpers, leaving the Tailwind versions as the defaults. So in the end, when Bootstrap was finally removed, it would lead to no line changes for all the Tailwind-related helpers and partials. In this project, I could have done it better in at least two cases. The first you may have noticed already. I could have set the CSS framework helper method to default to Tailwind and overridden as Bootstrap and all the subclass controllers to start with, and then just remove that as I work through each controller. The second case was the form builder. I needed to add a new Tailwind-specific form builder, and so as I went along, I was updating each form to specify that new builder. When it might have been better for me to first designate a Bootstrap form builder and update all the forms to explicitly use it, then create a Tailwind form builder and set it as a new default, and then fall back to it as I incrementally work through the forms. With the structure in place to convert to Tailwind, I started the process of converting views, working roughly from least to greatest risk. So starting with low traffic admin views for internal staff, and moving slowly to those higher traffic end user views. I would typically convert all views for a single controller at once by migrating overriding the CSS framework method for that subclass controller and updating its related views together. When doing this, it's important to watch for views that may make use of partials in other directories that may be primarily used by controllers that haven't been converted yet. This is actually one of those reasons why having that inventory and clarifying the dependent relationships between inventory items is important. This work is tedious, but it's because it's one controller or section at a time, it's easier to change, review, release, and move on without having to retain the context about it over the long term. As these inventory items get crossed off, you start building momentum and can more easily see what's left to do. At this stage, you'll inevitably notice ways that you could simplify views, abstractions you could extract, and other improvements you can make to markup and styling. But I would suggest you resist and just take notes. There are so many tempting side quests that will delay this journey. This is perhaps the greatest risk, that your well-intentioned desire to improve the code you're working on keeps you from achieving the immediate goal of completing this transition. So in one final PR, I removed the Bootstrap Sass gem, the Bootstrap CSS entry point, remaining style sheets only in place for Bootstrap, the CSS framework helper, and all its conditional checks, and all the Bootstrap-related namespace partials and helpers. The fatigue of the incremental steps may lead us to skip this phase, but that final red PR should be seen as a reward. Even though there's no functional difference to the system in this last change set, it's symbolic. I think we underappreciate the psychology of developers. We want to do the right thing. We want things to be clean, tidy, and neat. The satisfaction of completion provides a needed refueling and reinvigoration for the toil and tedium of that conversion stage. This strengthens resolve for that next migration project and period of limbo. This whole process took about 3 months of calendar time with a total of 30 PRs. Okay, now let's talk about a different kind of transition, one that has to do with architecture and data modeling. So I was working on a client project facing challenges because Stripe billing and subscriptions were coupled to the user model. It might be common wisdom nowadays that if you're building a SaaS, you should start with an account or team model and connect your billing and subscriptions to that, and not directly to the user model. But I don't know if that was as well understood over a decade ago when payments were first introduced into this app. We knew that subscriptions and billing ultimately didn't belong as a responsibility on user, but the work to migrate to that new solution would be both extensive and critical. As with the previous example, I knew that I didn't want to maintain a long-running branch for this project, and I didn't want to create a crisis point with an all-at-once switchover. I also couldn't block other work being done in this app, but I needed to minimize the transition time as much as possible by avoiding side quests. So with all of that in mind, here's how I approached the project. First, I needed to do a review of the system. This involved understanding what subscription and billing related data was being stored within the system already, as well as categorizing and mapping all the billing related processes in the app. I didn't write the billing code myself, so I went through and wrote documents where I listed out all the classes and methods related to billing and subscriptions and described their purpose in plain English, and then listed all other parts of the system that called them or relied on them. I also wrote documented questions I had about how the system was intended to work and about parts of the system that appeared not to be in use anymore, so I could discuss and get confirmation with the product owner. In the CSS framework migration, we were willing to live with close but not precise visual parity. Here, we needed all aspects of subscriptions to work exactly the same as before. In the future, extracting billing from the user model would open up additional benefits, but immediately following this migration, there would ideally be no functional difference to the system. My review left me with a few inventories. One was all the database-related columns related to billing and their respective active record models. These would inevitably need to be extracted from a direct relationship to the user. The other type of inventory was all the list of all the parts of the system down to the method level that related to subscriptions and billing, which would need to change. In the review process, I looked for any tasks that could be performed ahead of the migration work that would simplify and reduce friction for me. In this project, I found that there was a lockout feature that would lock the user out of their account if there was a Stripe billing dispute. The lockout modeling and functionality was tied to the user, and this would not make sense to continue after moving billing up to the account level. But most of this feature was separate from billing, other than an event handler responding to a dispute event from Stripe. So I moved this functionality to the account level ahead of the migration. With a good understanding of the system, my list of inventories, and the preliminary tasks complete, I would now set up everything I needed to start the migration. My plan was to create a new model holding billing subscription data, work through the whole system to dual write to both the old and new locations, have a verification script that would check that the values were the same between origin and destination, and then after completing dual write and verification steps, I would change the source of truth to the new model, and then go back through the system and remove writing to the old location. For the setup, I created a new billing accounts table, the billing account active record model with a way to sync individual records from their origin, a script that would force sync all records from origin to destination, and not pictured here, a script that would also verify data parity, and a checklist for working through the entire system to make the changes. I created the billing account model on a user sign-up and ran a backfill job to create and sync billing account models for all existing accounts so that all of them would have an associated billing account with a current snapshot of data. From there, I was ready to move into the incremental migration portion of this project. These migration steps are broken down into 3 main sections: dual write, change source of truth, remove original. For dual write, I would take a method or a background job and change its arguments from the user to the account or billing account. In cases where data was persisted, I would create a transaction around the original persistence call, adding the corresponding call to change the billing account. I would leave a to-do for myself at each incision point so I knew all the places I would need to return and remove the old call. After verifying that the dual write phase kept data parity, I was ready for the change source of truth, where I would start relying on that new billing account data within the system, whether it was the trial period, the expiration status, or etc. At this point, I was still using the verification script to ensure that we maintained data parity with the new model. Finally, for the remove original phase, I would work back through the system and remove all original persistence calls with the transactions wrapping them. At this point, I would no longer be able to rely on that verification script, but I had confidence that we had parity and we were now fully relying on the new model as the truth of the system. Each of these change sets were scoped down PRs that could be reviewed and deployed easily, could be rolled back if necessary, and could be monitored to ensure successful use in production. By giving each change time in production, I could gain confidence both in observing the code's usage as well as verifying data parity with the verification script. Discrepancies didn't happen often, but one example I caught was that when I persisted user email address upon sign-up, Devise would automatically downcase the email on the user record, but I hadn't done the same thing in my billing account record, so my case-sensitive comparison script caught the difference. To fix this, I mimicked Devise functionality to downcase and to strip the email using active record normalization, deployed, reran my sync from origin to destination, and gave it more time to surface other issues. Finally, I was ready for the teardown. After several months of work on this project, it would have been easy to stop here and not complete this last step. But doing so denies the full satisfaction of seeing the system simplified. And it denies others the opportunity to release their former knowledge about how the system worked previously. I removed all remaining references to the old billing and subscription data on user, including in tests and factories, and I removed the now unused columns on the users table. This whole process took around 6 months in calendar time with a total of 42 PRs. As I've worked on various kinds of migration projects like these over the past few years, I've had this feeling that perhaps there was some overarching pattern here, regardless of whether the change was to dependencies, schema, or data process. So you've seen it twice already, but let me lay it out plainly. First, I see 3 main stages representing before, during, and after the transition. Within those, we have the following phases. We start with discovery of the system, what it will mean to make the transition. We may have a sense of the changes to be made, but we need a deep understanding of how the system currently works, and we also need to get clarity about what the end state will look like. So discovery should produce 2 things, destination and inventory. The destination may be obvious in some cases, but it may not always be. We may be defining a new data model to replace an existing structure, or we may be rewriting an algorithm. But no matter what, we need to define what parity will mean between the current system and that goal state. In the first example, parity was more subjective. We didn't require a pixel-perfect match between CSS frameworks, but we didn't want a jarring experience for users navigating between old and new layouts. In the second example, parity was objective. We needed precisely the same functionality for billing and subscriptions before and after the transition. Inventories will look different depending on the type of migration. In the first example, it was a list of views, partials, helpers, bootstrap extensions, and so on. In the second example, it was a list of all the billing-related attributes being stored, as well as a list of all the methods accessing and changing those attributes. In both cases, this involved understanding dependencies among those items. The inventory helps us plan the steps to take, helps us track our progress, and can also be useful for estimating time and complexity of the project. Now we have a good idea of what our goal state is, as well as a better sense of the scope and complexity of the project. This is a good checkpoint to pause and reconsider if the migration is still worth the cost to the team. If we want to continue, there's likely more we can do to reduce both the complexity and the calendar time of the project. During discovery, we likely identified preliminary tasks that could be completed before even starting that transition. This is the kind of work that could or should be done to improve the system regardless of whether we continue with the migration or not. The more we can do before starting that transition, the more we can improve the chances of success in making it through that limbo period. When the preliminary tasks are complete, we again have more information about what it will take to make this transition. We may again evaluate whether or not to continue with this project. Now we enter the setup phase. At this point, we've begun the transition, and until we reach the teardown stage, we have to hold a conceptual understanding of the current state and the final state of the system. For this reason, we want to keep this period of time as short as possible. Setup work is different from preliminary tasks in that it's the particular staging work needed to allow the incremental changes to be made leading to that final state. This may mean adding new dependencies or new columns and tables, duplicating views or helpers or classes, setting up a structure to switch back and forth, adding the ability to transform and sync data, and building methods of verification. Now we enter a phase of incremental steps, usually iterating over those inventory items as smaller units of work. Not all units will follow the same process, but many will. The important part is that each step is short, easy to review, verifiable, and reversible. In my experience, it's not necessary to plan out all of these incremental steps in order ahead of time. Instead, if you have the goal state in mind, have your staging in place, and your inventories to guide you, you can often find the next piece of work that can be done without disturbing other parts. When I was a kid, we played a game called Pickup Sticks, where a bunch of long colored sticks were dropped in a pile, and each player took turns trying to remove one stick from the pile without disturbing the others. It would have been nearly impossible to plan the removal of each stick in order at the start of the game, but when it was your turn, all you had to do was choose the next easiest stick to remove, and then the task was achievable. One benefit to incremental steps is that it uncovers lack of understanding and incorrect assumptions earlier in the process. As much as you may think you understand your app as it currently exists, as well as that end goal state, you will inevitably be surprised by something along the way. Making small, incremental changes increases understanding and surfaces insights that can help you make adjustments sooner and increase system and project confidence. While the pattern for incremental changes will look different based on the type of migration project it is, each step should involve some kind of verification, which may be at the unit level, the system level, or both. Automated test coverage is one part of this, but it may also involve manual testing and verification scripts. For the CSS framework migration, the unit level verification was manual page-by-page visual comparison. For the billing migration project, the system level verification was a script that could check data parity in production across all accounts between the old and new data structures. In some migration projects, there will be a change to the source of truth, and it may not happen at the end of the incremental steps. In my second example, there was a first pass through the system to dual write to both old and new data locations. After the verification of parity, we changed the source of truth and then made the second pass through the system to remove writes to the old location. At this point, we're through the transition, but the work isn't quite done. If you repaint your living room, the work isn't complete as soon as that wall color is changed. The paint cans, ladders, and drop cloths still have to be put away, the painter's tape carefully pulled down, and the room put back in order. The teardown work is the final phase of removing the remnants of the original state, as well as the structures that were created just for those incremental steps. When the teardown is finished, we could finally release the knowledge we've held about how the system worked before. This phase is easy to neglect, as there may be significant fatigue after the potential long haul of all those incremental steps. But completing this phase provides emotional relief, the release of cognitive burden for the team, and a satisfaction that should not be underestimated. So, why talk about all this? What's the benefit of naming this scenario and defining a process for these transitions? Here are my reasons. First, I think the work of these kinds of transitions is often underappreciated, ignored, or simply not recognized. As Carl Jung noted, until you make the unconscious conscious, it will direct your life and you will call it fate. Without recognition and appreciation for this work, we are subject to forces we assume are external or outside of our control. All the work we do deserves to be visible, conscious, recognized, and appreciated. It's important to the understanding of the total cost of ownership of software. It's important for team morale. It's important for planning and resource allocation, as well as system knowledge and comprehension. Second, because this work is less visible and less recognized than something like feature development, for example, we frequently start transitions that we don't finish. I think this happens because we underestimate the time and effort it will take to complete the transition. We lack a process that keeps us from getting lost or sidetracked in the middle. And we fail to fully persuade our team on the benefits we all gain by reaching the destination. Instead, we start the ambitious work optimistically, get distracted by side quests in the middle, lose momentum as the time expands beyond our expectations, and the work eventually gets deprioritized as the costs increase and the initial urgency and clarity are lost. Third, when this work gets deprioritized, we are still left in limbo. The software system and our team's understanding of it are still out to sea. We've left one shore of safety and haven't reached the other, and the additional risks and effort we took thinking it was all temporary is now permanent. When we leave these transitions unfinished, we teach our teams that this is normal. We embark on other transitions, but now with precedence for not arriving at our planned destination, devaluing the gains to be had, and reducing both the credibility of our plans and the certainty in the minds of our team members. The risk and cognitive load compounds the more projects are in limbo, but we gradually come to just accept this additional overhead. And perhaps the only time this is questioned is when we onboard a new team member and must explain why half the code base uses one pattern or library or data source and half uses another. And ultimately, we deny ourselves the resolution and satisfaction of arrival. The relief and release of cognitive burden when we can forget how the system worked before, and the confidence that we can complete extensive, cross-cutting work when we set out to do it. This doesn't have to be our fate. By correctly identifying our circumstances, creating clear processes for ourselves, and recognizing that hidden work, we can increase our odds of success and enjoy the rewards of the destination when we find ourselves in limbo. Thanks.